Alright, hi and welcome to this new video, and today I will show you how you can implement a Perlin noise function to create islands. And I will go through complete oh my god, the code and everything else. If I sound, if I cough and stuff like that, that's because I'm currently pretty sick. Hopefully I will get better, that sounds like a pretty nice thing. But yeah, hopefully you get through with this, okay? My voice doesn't, mess up everything. Let's get started. So, step one, what we will do is we will create a texture 2D of the Perlin noise. So we will start by that. And actually, I'm sorry, when I say Perlin noise, I don't mean actual Perlin noise. I'm gonna do simplex noise. Please, this is not clickbait. Don't click away from now, okay? But basically, what simplex noise is it's a much simpler version of Perlin noise, and it takes way less time to compute. So it's a way to optimize your games, and this is what actually most games do. And how you can set up simplex noise is simple. You can just follow me here. So we're gonna go to Window, click the Package Manager, and oh, okay, I already done this, but if you go to Packages, Unity Registry, it's not in project, but Unity Registry, and search basically for mathematics, you will find it, and in here it's gonna say like install or update or whatever, and you want to do that, and you can see I already done it. So okay, and now we can use simplex noise. So next we're gonna create an empty game object. We can call it manager or whatever you want. We can reset it, doesn't really matter. And we'll go ahead and create a new script. Let's call it Perlin noise. You can see I already played a bit with this, but yeah, just gonna do a new script, create an add, and okay, now let's get going. Okay, so first we want to implement using unity.mathematics so we can use the simplex noise. Also, I just want to say, please let me know if typing annoys you, because I bought a new mic and I don't know yet how just like sensitive it is, so please let me down in the comments if you find it annoying, and I'll try to fix it as much as I can. Anyways, unity.mathematics. Next, okay, so we're gonna declare a few variables. We need a size. We also need scale, public float scale, and that will just mean just how zoomed in we are into the Perlin noise. I will show you later on exactly how it works. And we're actually gonna have this in a range, which is gonna, because we don't want this to go beneath 0, so we just want to make sure that doesn't happen. And I don't know, let's set it to 20 or something. It doesn't matter how high you go, it just matters that you don't go beneath 0, because then the code can mess up. We also need a public renderer. We will also need a color array, which is gonna hold all our pixel values for the texture. Later on, don't worry, don't go yet, I will convert this into 3D actual islands like I showed you in the intro, but this is just to get the noise set up. We also need the texture 2D noise text. Okay, so noise texture is gonna be equal to new texture 2D size. So the width is gonna be size and the height is gonna be size. What you can do is you can have special variables called like width and height, but I'm just gonna have a simple grid of them, and the rest we don't care about on the texture. Then we also need to instantiate the color array is equal to new color, and this is going to be equal to size times size. Oh yeah, I forgot. So we're gonna have noise texture, and we also want to make sure that our renderer dot share actually uses that texture. You know, that seems pretty important. Noise text, there we go. So now we set up our, you know, basic stuff. Now let's get into the Perlin noise. So we can actually create a function called noise, or we could do get noise at float x. Actually it's going to be int x and int y. And what we're gonna do for now is we're gonna create a new variable which is gonna hold this value, and we actually have to calculate a new x. Oh my god, okay, my throat hurts so much. Okay, maybe I don't think this was a very smart idea. I think I should have just waited for me to get better and then create this video, but let's actually scale. But okay, we're fine. If I die, then it's, you know, it's fine. Okay, float, and this is just math. Okay, just don't ask me how this works. No, I'm kidding. Well, basically, since our Perlin noise has to go between 0 and 1, so this just clamps it to it. So we're gonna have scale, and we do pretty much the same with both the x and the y. And we're gonna have float value is equal to noise dot s noise, and this is what the simplex noise is. And we're gonna do new float 2 with the nx and ny. So now we have that value. Now we're gonna do e is equal to plus equals math f dot inverse lerp between 0 and 1 and the value. And this just makes sure that it all goes between 0 and 1, because in this step we're gonna have a gradient, like a color gradient, which actually I forgot to add here. Okay, public, oh my god, what the, no, I don't want source control. Public gradient, color gradient or something. And what we can do is just simply return e for now. And then in our update method, we're gonna have a nested loop, since we have a 2D Perlin noise. X is 0, x is great, s is less, oh my, x is less than size, yes, that's what I want to say. Boom, just copy paste it, and we're gonna have y and y. Okay, well, we want to get the noise every time. Well, actually, for now we want to evaluate that noise with the gradient, so we get a color back. Okay, yes, we want to get before here we actually want to set a new variable, I is equal to 0, and here we want to increase it, just so that we can get our color array is equal to the color gradient dot evaluate and get noise at x and y. And what this evaluate function does, it basically returns a color in that special like time key. So if we have, for example, let's say at 0 it's the color black, and at 1 it's color white, and if the float get noise is going to be equal to like 0.5, for example, well, that's going to return a grayish color. So that's what this basically does. And then here we just want to do noise texture dot set pixels, and we just need the color array, and then we just apply it. And I think that should be it, actually. And here we can set our color gradient to be like, so that's what I said. At 0 it's gonna be black, and like at 100% it's gonna be white, and so something in the middle is gonna be like grayish color. Now we also need a renderer, so we're gonna create a quad. If you want, you can also add this script to the quad, but I like to keep all of like my main scripts on one manager, one empty object. And we can increase it to, let's say, like for example 50 by 50. Add that here, and also keep here 50. And oh my god, there we go. Okay, so we have Perlin noise, and you can see what I do when I scale it up. It basically, like I said before, it zooms in or out. That's pretty much what the scale does. So yeah, I mean, that's pretty much step 1 completed. Alright, so on to step 2 or 3, or I don't know what language it is, but step 2 anyways. So what we want to do now is create an island. We're still gonna have this on the texture 2D. On step 3 we're gonna move to 3D. Don't worry, I'll get there. And how do we do this? Well, there's this actual great thing called Falloff map. And what Falloff maps do, wait, if I can just, I'm gonna play it and I'm gonna show you. So at the borders of this quad, it's gonna calculate a distance of 1, and the closer we get to the center, it's gonna be a distance of 0. And so what we're gonna do later is, remember how we created that variable e? Well, we're just gonna subtract it with the value of the distance. So this means that the more we get closer to the center, the more unaffected it's gonna be. But the closer we are to the border, the more it's gonna get subtracted, and that way it's gonna look like water mainly by the borders. And that's how we can create islands. And there are actually a lot of, plenty of Falloff maps. They all depend on the exact type of islands you need for your own project. I'm gonna leave a link down below with a few of the Falloff maps and also the math behind them and stuff. The one I'm gonna use on my project is called Square Bump. This means that I'm gonna have mainly one main island in the center and the rest is gonna be water. I'm gonna show you how it's gonna look. But yeah, and we can actually pretty much just get started on it. We're gonna create a new function, float square, actually I'm just gonna call it Falloff map, float x, float y, and we're still gonna create a new x, and this is just gonna be quite some math. Okay, for every Falloff map there's gonna be a different map and different things we use. So yeah, I'm just gonna copy it. Okay, I know, I'm sorry. Can actually introduce a new variable called exponent, and exponent, add it here, and then times pretty much this thing. Yeah, I could just take this, but it's gonna be ny. I mean, that's pretty much it. And we're gonna do return distance. And now we can simply do return e minus equals the Falloff map at x and y. Okay, and I mean that should pretty much be it. If we go back and actually do this, and we can actually, this is gonna mess up because we can't have our exponent at 0. And yeah, see, it creates like a kind of a mini island basically. Let's see. And this exponent okay, I paused it at a very good time. So we also have to make sure it doesn't go beneath 0 or 0. And for some reason, every odd number, it just messes up. See? And 5 and 7 and 9. I don't know why, but see, if we do like even numbers, like 4 or 6 or 8 and so on, it's fine. So I don't know why this happens, but just math is sometimes weird, I suppose. What we can also do while we're here, we can have a public int x offset, and actually it's going to be a float, it's better to be, there we go, and y offset. And we can just do plus x offset and plus y offset. There we go. And this is gonna introduce us to a couple more variables which we can use. For example, see, now I can move with all of my islands. And I mean, yeah. Now you may think, wow, this looks boring, what the hell? And yes, actually, oh my god, sometimes my coughs are like at perfect timing to just ruin the moment. Anyways, okay, the point I was trying to get into is this does not look very detailed, does it? So now I present to you something called octaves. Now what octaves are basically multiple noise functions layered on top of each other. Woohoo, yay, there we go. Okay. And we can actually set it up very, very easily. So we're gonna also have a range. We must make sure that it's not 0, because if we have octaves as 0, then we don't have any noise, and you know, that's not what we want to do. And we can also set it to like 20 or something. Public int octaves. There we go. And what we can simply do is just do for int I is equal to 0, I is greater, or as long as I is less than octaves, I plus plus. And what we do is we're just gonna copy all of this into here, and that's it basically. Now we have octaves set up, and I can show you what it's gonna do. Okay, and go back to scene, and wow, look at this. So this is what it looked like when we have just one, and see, it gets more and more kind of detailed, and you're gonna see this even better once we create like actual islands. Yeah, so we're starting to get somewhere. Okay, that's nice. Okay, I mean, that's pretty much step 2 completed as well, so on to the next one, huh? Continue on to step 3, which is gonna be actually converting this into 3D. And just, okay, I'm just gonna take a quick moment here. If this tutorial helped you any bit, please, you know, leave a subscribe, please. I'm begging you. I am currently on my knees, okay? No, I'm kidding, but, or just leave a like, you know, or in the comments, just tell me any kind of feedback, and yeah, subscribe, like, dislike, I don't care, just do something on my channel. Okay. No, okay, so let's continue. Okay, I just took a quick break. Still sick, obviously, and okay, yeah, I mean, we can just continue. And okay, some kids are screaming, what the hell? I don't care. Okay. So for now that we are gonna be converting into 3D, you're gonna have to make a couple of choices. I don't know exactly how your project is set up, but I'm gonna have cubes as like instead of pixels, you know. So until now we had pixels on a texture, but now we're actually gonna have like a cube. And I don't know, for you it might be like a triangle or something like, or like mesh. If you have anything like that, I will not be taking that into consideration in this tutorial. I will mainly show you how it's done with cubes. Yeah, just, you know, quick side note. So, and what will we need? Okay, we can actually oh no, we can keep it. I thought maybe we can remove the texture, but I think we can keep it for now. Anyways, so we're gonna need a game object, obviously the cube, to spawn in, like our prefab. And okay, here we go again. And we're also gonna need a game object to the array, okay, because this is, we're talking about a 2D noise here. So yeah, we're gonna have objects, and we will also need another 2D array of the elevation, and this 2D array will keep all of our like y values, because y is the one that we are gonna be changing constantly. And yeah, obviously we have to instantiate it. Objects, new game object, size, and I mean same with the elevation as well. This is gonna be a fruit. There we go. Okay, and then our like logic is pretty much done. You know, we did it in the first 2 steps of like the actual Perlin noise. So this is gonna be pretty simple. And what we're gonna do is simply elevation at xy is gonna be equal to well, it's simple, just get noise at xy, and we already created the Falloff map and stuff like that. So objects, well, yeah, objects xy dot transform dot position is equal to new vector 3. It's gonna be, so the x and the z stays the same, This is gonna be, there we go, and this is just gonna be elevation at our XY. Now, okay, I can actually show you, and this is gonna work pretty much. I can show you, but actually I can't show you because we have to instantiate, we have to spawn in all of the tiles. So, I mean, yeah, we just do another nest. As you can see, there are a lot of nested loops, but it's fine. Like I said before, the simplex noise takes less power and like computer power, I guess you can call it, to create, so no, you don't have to worry much about FPS. And plus, in my game I will only spawn in a random island at the start, so it won't be every single frame as we do in the update function. But yeah, okay, so we're gonna do objects at xy equals to, and can we just do instantiate? Yeah, we can. Okay, and it's gonna be the cube. We're gonna spawn them at x plus 2, new vector 3, x plus 2, 0, and z plus 2. This plus 2 just makes sure that there's enough spacing between them. And quaternion dot identity, which mainly means we don't care about the rotation, it doesn't matter. And they created a prefab. Okay, this you don't have to care about it, this is just for my project, you know, we can turn it off, it doesn't really matter. And I mean, yeah, there's nothing special about it. So put it in here and let's try now. Oh, okay, well, it seemed like it spawned behind this thing. But yeah, there we go, that's pretty much. But you can see that we have a bit of a problem, and that is that our y values might be too little. You know, I mean, it might work for you, but I want to have a way to, you know, play around with this. So what I can just do is I can have a public int, something like multiplier or something, and we can just end here times multiplier. Nothing too special about it. I can show you what it does. I mean, you probably already know what it does. And yeah, since our multiplier is 0, and see, I can scale it up, but now it looks kind of ugly, you know. And in my project I don't want these holes to appear, and I'm pretty sure neither do you. So what we can do is simply round to the nearest integer with a simple math function, math.round, and there we go. And you'll see now that this is actually okay. Yeah, I might, you know, later on remove the quad, but yeah. And you can see endwise. Oh yeah, it's because the multiplier is too much. So it did technically round to the nearest integer, but yeah, you can play around with it, have maybe some different functions. For now I will just simply scale down it until there is no hole, and there we go. There we go. And now I'm just gonna show you quickly just the change that this does. I will also turn on. Okay, now you can see just the thing that it details it a bit better. Okay, I forgot to add it since I'm so dumb. Okay, I know. Forgive me, please. Anyways. Okay, but that's it. That's mainly what I wanted to add. We can get on to the coloring part. I mean, technically there's not really that much stuff we need to do. That was my chair, if you're wondering. I know it's a bit old. Okay, don't. Anyways, we can create is objects x y dot get component renderer. So we mainly want to do pretty much the same thing as what we did before, but now there's going to be material dot color is gradient. It's called color gradient. No, that's not. Dot evaluate. And I mean that's pretty much it. Get noise xy, and we can check. So if we have this basic color gradient from black to white, we should be seeing some. There we go. And let's just disable this for now. And there we go. I mean that's pretty much the coloring completed. However, this doesn't really look like an island, does it? And that's why gradients are so cool, because now we can put like, I don't know, a bluish color for the ocean, see here, and then some sand here, land, this is gonna be like grass or stuff, and then we can start having a bit more rocky, and then a bit more darker, and that's pretty much it. You can play with this however much you want, and we can also have like fixed if you want to, but I prefer blend, and that's what I had in intro. And yeah, and I mean we're pretty much done. I mean this is like my first ever tutorial on anything Unity related, and I just had to become sick, you know. But I didn't want to wait more longer, because I want to try and stick to at least one video per week, you know. But yeah, and this is pretty much it. You can see how different things, different variables affect stuff. And this is what I meant before. See, the octaves are just like layers on top of different Perlin noise like layers. And yeah, you can see it kind of lags if you have 20 of them. But hey, you can optimize this however you want. You can have 4, 6. You can even have the multiplier, which yeah, kind of messes up stuff, but completely fine. But yeah, okay, I mean, thank you. So I don't know really what more I can add. Thank you so much for watching. If you enjoyed it, please subscribe, like, and again, if you need any help with this, I'll be more than happy to help you as much as I possibly can. And yeah, this is my third part of a series where I create my own game, and this is one part. This is gonna be a starting island, so you can also check out that playlist if you want. Thank you, and I'll see you guys some other time.